Okay, so looking at sectors and segments. This line here, this is the B. Yep, it's an arc. What is the name of this? Anybody remember from last year? No. It's a segment. Okay, so the area part is a segment, and the name of this line. Anybody know the name of the line? No, that's not a tangent. Yep, this is a chord, and just this one. Yep. And just to be clear, just in case, because some of you, because you mentioned it, the tangent touches the circle how many times? Yeah, once. Okay, so that is not a tangent. That is a tangent because it touches the circle once. Okay, but we are going to look at specifically arcs and sectors and segments today. If I was to ask you, let me. Sorry, one sec. I want to copy this picture, copy image. Sorry. Okay, I have got a circle and I want to work out the okay, and let's say that the angle in here is theta. How would I work out the, let me just let Tyler in, how would I work out the area of this sector? We'll call it. Yep. Yep. And so what is the area of a circle? What's the formula? Okay. And if I want this fraction of a circle, how do I work that out? Well, let's do degrees. Well, no, it's theta. We don't know what angle it is. Right, good. So you work out it's theta over 360 because it's the angle. That's the fraction of the circle, and this is the area. Does everybody remember this from last year? Okay. And if we were then going to do it in radians, okay, so this is in degrees. This is the formula for in degrees. If I wanted to work it out in radians, what is 360? Somebody in SL, what is 360 degrees in radians? Silence. Come on, what's 360 degrees in radians? Marco, what's 360 degrees in radians then? 2 pi? No, 360 degrees in radians. Yeah, it's 2 pi. Okay, so what I'm going to do is to work out the formula in radians, I'm going to replace the 360 degrees with 2 pi because that's what it is in radians. I've got pi r squared. What's going to happen are pi's. Yep, cancel out. So I'm left with the formula theta over 2 times pi r squared. okay, where theta is in radians. Okay, so that is the formula you would use if you are dealing in radians. This formula here, okay? This is the formula you use if you are dealing in degrees, okay? So they do differ. You can't use the same formula. You need to make sure that you are using the correct formula. I'll do an example with this in a second. Let me just do the formula for our arc length. Okay, let's say we wanted to work out the length of this arc, okay, that I have not drawn very nicely. Okay, how do I work out the length of an arc? Right, good. I'm going to use the formula for circumference. I work out the full circumference of the circle. I only want a fraction of it, so it's going to be 2 pi r multiplied by, say again, theta over 360, right. Do you remember that from last year? We are now just working out what the formula would be if we are dealing in radians. So we said 360 degrees in radians is 2 pi. So what happens to 2 pi on the top and the bottom? They cancel, and I'm left with Jeden. Yeah, theta times r, good. So this is the formula for the arc length where theta is in radians. This is the formula where theta is in degrees. Okay, so you can see that the formula to work out the arc length is actually easier if you are working in radians. It's just the angle times the radius. Okay, I'm going to have a look at 2 questions and then I'm going to let you go. Find the arc length and the area of the sector of the circle. Okay, so we said the formula for arc length is theta times the radius. What is theta? Three pi over 4, and we're multiplying that by 8. Okay, and that's the same as 8 over 1, so 3 8s are 24 pi over 4. What's 24 divided by 4? 6. So my arc length is 6 pi, okay? And if I wanted to actually work that out, that's in terms of pi. But if I wanted to work it out, it would be 18.8 centimeters to the nearest decimal place, to the 1 decimal place. Easy enough? Okay, the area of the sector. We said the formula was theta over 2 times pi r squared. We're having to use these formulas because we're dealing in radians. So theta is 3 pi over 4 divided by 2 times pi times the radius, which is 8 squared. I can put all this into the calculator if I want. What's 3 pi over 4 divided by 2? What's that going to be equal to? How do I divide fractions? Somebody from SL? Yep, keep, change, flip. So I get 3 pi over 8. 3 pi sorry, let me just have I sorry, I've written the formula down wrong, haven't I? The formula is theta. Yeah, theta over 2 times pi r. Sorry, the formula is not that. My mistake, sorry. The formula is theta over 2 times pi r squared. Let's just go back to our formula. Pi's cancel. Sorry, guys. That is our formula. Okay, the pi's cancel out. Theta over 2 times r squared. Okay, sorry about that. I was wondering where I was getting that extra pi from. Ooh. So that's my theta over 2 times r squared. So 3 pi over 8 times 8 squared is 64. How many times does 8 go into 64? 8 times, good. And then 3 8s are 24. So in terms of pi, the answer is 24 pi. And to the nearest decimal point, or sorry, to the nearest, one decimal place is 75.4 centimeters squared. Sorry, does that make sense? Let me just change. Sorry, I don't know why I've done that. That should just be, the formula is theta over 2 times r squared, okay? Make sense? All right, what about this one? If I want to find the shaded area, thoughts on how I'm going to do this? Oh. Okay, how do I... Yep, that's good, area of the sector, so let's just quickly do it. And then minus what, Ari? Yep. Right, okay, so there's our area of our sector. The angle is 2 pi over 3. So 2 pi over 3 divided by 2 times the radius squared. So that's 2 pi over 6 times 36. 6 goes into 36 6 times, so I get 12 pi. I'm just going to leave it in terms of pi. So that's the area of the sector. The area of the triangle, how do I work out the area of this triangle? Can you be more specific? Okay, but if I want to, I don't want to find the side length, I just want to find the area. Do we know any formula for the area of a non-right angle triangle? Half. Yeah, half AB sine C. So this is where all this stuff is going to come in now. So we've got half of the two sides and times sine of the angle in between. So half of the two sides times sine of the angle in between. We can work out what that is. And you have to make sure if you're putting this into the calculator that your calculator is in degrees, okay? So we get 15.589. So the area of this segment, the shaded part, we take the full sector and subtract off the triangle. Sorry. So 12 pi minus 15.589. And I get 22.1 centimeters squared. Okay. Questions? If anybody would like me to go through this individually with them, I am happy to do that. I have recorded this, so I will post it just in case you need to go through it. I know I've gone quickly, but I did not want to spend the whole time on Zoom, just so that you can actually get the practicing. SL, this stuff is on page 512, 513, and HL, yours is on page 383. I will put that in Teams, and I'll put this video in Teams as well and on YouTube, so you can have a look and have a go at some of these questions, okay? But essentially, these are the formulas that you need to use for radians, arc length, and area. Okay? Any questions? No? Let me just check we've got everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, so we're good. I will go. I will let you have a practice at this, okay? Please email if you have any questions, if you want me to go over any other exam questions or anything else in particular. Please do. It's not like I'm going anywhere or doing anything else, so I am happy to do whatever you want, okay? If I'm going too fast or if you want me to go over any of this again, I'm happy to have another session with you individually, or if you want to have a group session, that's absolutely fine, okay? Yes, Jen. Yeah, 383, yes. I'll put it on Teams as well, okay? No worries. All right, guys, I will catch you later, okay? Have a good weekend. Bye. See ya.